There's more than 2 million traumatic brain injuries a year in the United States. There's more than 100,000 concussions in high school football alone. And concussion is diagnosed on the basis of signs and symptoms. By the time changes in the brain have manifested as changes in behavior, potentially the damage has already been done.
The brain is the most complex organ with 86 billion neurons, 100 trillion synaptic connections, and these are all joined together in networks and fiber tracts. These fiber tracts constitute the white matter of the brain. When there's acceleration, deceleration, or rotational forces to the brain, these white matter tracts can be damaged.
The injury that can be caused by head impacts in contact sports is clinically silent. So can we develop a technology and can we develop a scientific approach that allows us to predict when changes are happening in the brain prior to the emergence of those changes in signs and symptoms? Over the last decade, it's become more and more clear that some of the injury that's caused by contact sports like football is not caused by concussion, but by the accumulation of many repeated head hits. So we want to build digital twin models that allow us to predict when clinically silent injury might be accumulating inside of a football player's brain before it starts to show signs and symptoms of injury. We enroll cohorts of contact sports athletes in our study, and we follow them before the season, during the season, and after the season. We measure what's happening inside their brain, their psychomotor performance and their ability to make fast reactions. And we also measure all of the head impacts to which they're exposed throughout all of practice and play using accelerometer-embedded mouth guards. We'll be able to have a complete picture of how the head impacts that are commonly associated with playing collegiate football actually translate to changes in players' brains.
Hippocrates said the first responsibility of a physician is to prevent disease. This work will have significant implications in terms of long-term damage. Showing the tractography and the white matter changes would be a huge advance.
Ultimately, the lessons that we hope to learn from our research will generalize well beyond football.